All right, so get ready, because today we're diving deep into this AI thing, this new model, DeepSeek V3.
And yeah, it might just sound like, oh, another AI.
Another day, another AI.
Right. But DeepSeek V3, this is something else.
It's wild.
Yeah.
671 billion neurons.
It's like, I mean, think of it as like a brain, right? But a brain with more connections than there are stars in the galaxy, it's just mind-blowing.
It really is. And one of the things that I think is so interesting about DeepSeek V3 is they trained it in less than 2 months.
Yeah, less than 2 months, and for only $5.5 million. Some of these other large language models, we're talking tens of millions just to train them.
Yeah, and this one is open source.
Yeah, that's a game changer, right?
Huge. That means anyone can go in and see how it works.
Exactly, and I think that's really important for the future of AI development, having that kind of open access for everyone to really push the boundaries of what's possible.
Absolutely. So let's dig into the paper a little bit here.
Um,
Now, DeepSeek V3 is built on something called a transformer model. Can you kind of explain what that is in layman's terms?
So imagine a transformer model as like the foundation of a house, right?
Okay.
It's a very basic structure that many AI systems are built on these days. So DeepSeek V3 takes that foundation and they add all kinds of cool new features to it. One of them is called multi-head latent attention, MLA. Yeah.
Multi-head latent attention, MLA. So what does that even mean?
Okay. Imagine you're trying to remember a long list of groceries, right? Multi-head latent attention is kind of like having this mental filing system in your brain that helps you remember things more efficiently.
Okay, so it helps organize information, prioritize, categorize it.
Precisely. So instead of trying to cram everything into your brain at once, you're organizing it, making it easier to process.
So it's like a more efficient way for DeepSeek V3 to process information.
Yeah, exactly, yeah. Another really cool feature is something called DeepSeek Mo, or Mixture of Experts.
Okay, DeepSeek Mo, mixture of experts. That sounds interesting.
It is. Think of it like this. You have a team of experts, right?
Good.
Each of those experts specializes in a very specific field. So you wouldn't ask a heart surgeon to build a rocket, right?
You'd want a rocket scientist for that.
Exactly. So DeepSeek Mo, it basically divides these complex tasks and assigns them to different experts within the model, if you will.
Oh, okay. So it's like you've got like a brain surgeon for brain stuff. You got a rocket scientist for, rocket stuff. And then maybe you've got, I don't know, like a chef in there to cook up some delicious code.
You got it.
So it's like a division of labor to make the model more efficient.
Yes, exactly. It's like having a team of specialists working together, each bringing their own unique expertise to solve the problem.
So it's a more efficient way to kind of break down these complex problems. But managing all these experts, I imagine, that must require a lot of coordination.
It does. And
Yeah.
that's where this thing called auxiliary loss-free load balancing comes in.
Okay, auxiliary loss-free load balancing. Break that down for me.
So this technique ensures that no single expert gets overworked. Think of it like a project manager, right?
Oh, okay.
Someone making sure everybody's got a fair workload and tasks are being distributed evenly.
So that's to prevent, like, AI burnout, I guess.
Precisely, yeah. It helps prevent overload and ensures that the whole system is running smoothly. But with all this processing power, I'm imagining you need some pretty intense hardware to run this thing.
Oh, yeah. I was just thinking about that. I mean, my laptop would probably melt.
Yeah, you're not wrong. So DeepSeek V3, they trained it on this supercomputer. It had 2048 NVIDIA H800 GPUs. That's a lot of processing power.
That's like what, a room full of gaming computers all working together?
Something like that, yeah. And they had to overcome a lot of challenges, too, communication challenges. When you're using so many GPUs, you have to figure out how to keep the data flowing smoothly between them.
So it's not just about throwing a bunch of GPUs at it. You have to have some kind of, strategic coordination there.
Exactly, yeah. It's about optimization. And they did this through something called the dual pipe training pipeline.
Dual pipe, huh?
Dual pipe. Think of it like multitasking, but on a massive scale.
Okay.
They're overlapping these different computational tasks to reduce the overall training time.
So it's like having two assembly lines working in parallel.
That's a good analogy, yeah. And they had to do a lot of clever stuff to make sure those assembly lines were communicating with each other properly.
Yeah, no traffic jams in the AI world.
Exactly. But even with all that, training a model of this size, it's expensive and time-consuming, right? Or at least you'd think it would be.
Yeah, but didn't they say it only took 2 months, though?
Yeah, well, that's because they used a new technique called FP8 training.
FPH.
FP8 training. It's like a secret weapon for efficiency.
Okay, tell me more. What is that?
Okay, so imagine you're baking a cake, right?
Baking cake, okay. I like where this is going.
You don't need to measure your flour down to the milligram.
No, just a cup.
Right. Exactly, yeah. A little bit of rounding won't ruin the cake. So FP8 training, it's kind of similar. They use lower precision for some calculations, which means they can use less memory and make the whole training process a lot faster.
Wait, so lower precision, does that mean the results are less accurate?
Well, it could, but they figured out which calculations can handle a bit of rounding without affecting the overall accuracy.
So they're like strategically being a little bit less precise in certain areas?
Exactly, yeah, where it doesn't actually matter.
Smart. But I'm guessing there are some challenges with that, right? Doing that FP8 training?
Yeah, there are. One of the biggest challenges is something called numerical instability. It's like when a recipe calls for a very specific amount of baking powder.
Oh,
A
yeah.
little too much or a little too little, and the whole thing can go wrong.
It's ruined.
Exactly. So they had to develop a bunch of strategies to make sure that didn't happen. Things like fine-grained quantization, increased accumulation precision. It gets a bit technical.
A little bit, yeah. I'm not going to pretend to understand all that.
Yeah, but basically they found ways to keep things stable even though they were using lower precision calculations.
Like using a more precise scale for your baking powder.
Exactly, yeah, where it really matters.
Smart. So that's the FP8 training. But I think we also mentioned earlier, DeepSeek V3 can handle a ton of information at once.
Right, yeah.
Like something like 128,000 words.
Yeah, an incredible amount of information. I mean, it can remember things from way earlier in the input, which means it can understand the context of what it's processing much better.
So it's like reading a whole book and remembering every character, every plot twist, every single detail.
Exactly, yeah. And they achieved this using a technique called yarn.
Yarn.
Yarn. It basically expands the model's memory capacity, so you're giving it more space to store all that information.
I mean, it sounds almost magical.
Yeah.
But how did they train this thing? What kind of data did they feed it?
Well, they trained it on 14.8 trillion tokens.
Okay, that's a big number, but I don't know what a token is.
So a token is kind of like a piece of a word. Think of it like you're breaking down a sentence into individual words and punctuation marks. That's a lot of data.
Yeah, 14.8 trillion. That's a lot of data. So what, do they just like feed it the entire internet? What kind of data was it?
Oh, it wasn't just random stuff. They were very deliberate about the data they used. They actually focused on mathematics and programming samples.
Interesting. So they wanted to create an AI that was really good at math and coding.
Exactly, yeah. And that's one of the reasons why DeepSeek V3 performs so well in those areas. They also use something called a fill-in-the-middle, or FIM strategy.
Fill in the middle. That sounds familiar.
Yeah, it's kind of like those exercises you did in school, right? Where you have a sentence with a word missing, and you have to guess what word goes there based on the context.
Right, yeah.
They trained DeepSeek V3 to do the same thing.
So they're like training it to predict missing information, basically.
Exactly, yeah. So it has to understand the surrounding context to be able to fill in those blanks.
That's really cool. So it sounds like we've got a pretty powerful AI on our hands here. But does it actually live up to the hype? How do we know if it's actually any good?
Well, that's the question, isn't it? That's what we're going to dive into next.
Okay, let's do it.
Welcome back.
So before we wrapped up part 1, we were talking about how DeepSeek V3 was evaluated. Remember all those benchmarks? Like putting it through a series of tests to see what it could do?
Yeah, the researchers really wanted to understand, how DeepSeek V3 stacked up against other AI models out there, so they really challenged it with all sorts of tests.
It wasn't just 1 or 2 tests. They really threw the whole book at it, didn't they?
Yeah, a whole range of benchmarks.
Benchmarks, what are those exactly?
Think of them like standardized tests,
Oh, okay.
designed specifically to evaluate these AI models.
Like SATs for AI.
Yeah, exactly.
So higher the score, the better the model. Is that how it works?
Yeah, pretty much.
Okay, so how did DeepSeek V3 do? Did it pass?
Yeah.
Give me the details.
More than pass. It aced the exams, really, especially when it came to those tasks that required like a lot of reasoning, a deep understanding of concepts.
Oh, wow.
Yeah. So, for example, one of the benchmarks they used is called the multi-subject multiple choice test.
Multi-subject, multiple choice, okay.
And it covers a really wide range of topics, from science, history, to literature, math.
So it's not just good at one thing. It can kind of handle a variety of subjects.
That's right. Yeah, it's a pretty versatile model.
Okay, that's impressive.
Yeah, and DeepSeek V3 scored 88.5% on this test, which is significantly higher than what a lot of other open source models have achieved.
88.5%, that's pretty impressive.
Yeah, it's a really strong showing.
But I'm curious, did they just look at like the overall score, or did they kind of like Break it down a bit further.
Yeah, they definitely dug deeper.
Yeah.
They wanted to understand, which specific parts of the model were contributing most to its success.
Like, what was the secret sauce?
Exactly, yeah, the secret ingredient.
Okay, so what did they find?
Well, one thing that really stood out was the contribution of the multi-token prediction strategy, or MTP.
Oh, right. We talked about that in part 1, right?
Yes.
That was the thing where it predicts multiple future tokens instead of just one, right?
Exactly.
Kind of like, I don't know, like a chess player that can think several moves ahead.
Yeah, that's a great analogy.
Okay, interesting. So that was a big part of its success.
That seems like it.
And what about that, the mixture of experts approach, that MOE thing?
Yeah, MOE, that's another key ingredient.
But, I mean, managing all those experts, that must be a bit like herding cats.
Yeah, it's a challenge for sure.
How do you make sure that they're all, working together effectively?
Well, that's where that auxiliary loss-free load balancing technique comes in.
Oh, yeah, the AI project manager, making sure no one's getting overworked.
Right, and to test how well that was working, they actually ran some experiments, comparing DeepSeek v3's performance with and without it.
Oh, okay, so like one version with a good manager and one version where it was kind of just chaos.
Yeah, you could put it that way.
And what happened?
Well, the results were pretty clear. The version with the auxiliary loss-free load balancing performed much better.
So having a good manager really makes a difference, even in the AI world.
It seems so.
But I want to, kind of bring it back to the real world here for a second. What does all this mean for, the average person? How is DeepSeek v3 going to impact our lives?
Yeah, that's the big question, right? And it's early days, but the potential applications are pretty vast.
So put on your, futurist hat for a second. What are some of the areas where you think this could make the biggest difference?
Well, one area that immediately comes to mind is education.
Education, okay.
Imagine a world where every student has access to a personalized AI tutor. Something that can adapt to their individual learning style and pace.
Oh, wow.
Yeah.
That would be amazing.
Right. No more one-size-fits-all teaching methods.
Yeah, that's a game changer.
DeepSeek v3. It has this ability to understand, generate human-like language, and combine that with its reasoning capabilities, and it could be a really powerful tool for personalized education. And not just for students either. Think about professionals who need to constantly update their skills,
Oh, yeah.
stay up to date in their fields. DeepSeek v3 could help them learn new things, keep up with the latest research.
It could revolutionize professional development and lifelong learning.
It could, yeah.
Okay, so education, that's a big one. What about other fields? Could DeepSeek v3 be used in scientific research?
Absolutely. Scientists are already using AI to analyze massive amounts of data, make new discoveries, DeepSeek v3 could really accelerate that process by helping them sift through mountains of data, identify patterns, even generate hypotheses.
So it's like having a superpowered research assistant.
Yeah, that can kind of crunch the numbers and spot connections that humans might miss.
Okay, that's really cool. But I know that, some people are concerned about the potential downsides of AI, things like job displacement, bias, even the possibility of AI becoming, uncontrollable.
Right. Those are all valid concerns.
So how do we ensure that DeepSeek v3 and other AI models like it are used responsibly and ethically?
Yeah, that's a really important question. And I think it starts with having open conversations, involving diverse voices, including ethicists, social scientists, policymakers.
Yeah.
We need to think carefully about the potential impact of AI on society and put in place the right safeguards to mitigate those risks.
So it's not just about, the technology itself, it's about the human values that guide its development and use.
It's about both, for sure.
Okay, but let's bring it back to DeepSeek v3 for a minute. We've talked a lot about its strengths, but what about its limitations? Are there any areas where it falls short?
Well, like any AI model, it's not perfect.
Right.
One of the biggest challenges right now is deployment. It's a big model. It requires a lot of computational resources to run.
Yeah, I remember we were talking about all those GPUs.
Yeah, it's not something you can just download and run on your laptop.
So not exactly user-friendly for beginners yet?
Not yet, but the good news is that researchers are working on it,
Okay.
trying to make it more accessible. And as hardware improves, those challenges will become less significant.
Makes sense.
Yeah.
Any other limitations?
Well, I think it's also important to remember that DeepSeek v3, like all AI models right now, it's still under development, right?
It's still learning.
It's learning, it's evolving, its performance can vary.
It's a work in progress.
Yeah, very much so. AI is a journey, it's not a destination. DeepSeek V3 is a big step forward, but there's still a lot more to learn and explore.
It sounds like the future of AI is full of exciting possibilities, but also some important considerations.
It is definitely.
But it sounds like, with careful planning and ethical development, AI like this could really reshape our world in a lot of positive ways.
Yeah, for sure. It's a powerful tool.
Well, that's a wrap for part 2 of our DeepSeek V3 deep dive.
Yeah.
We've covered a lot of ground, from the technical side to the more philosophical side of things.
Yeah, it's been an interesting discussion.
But we're not done yet. In part 3, we're going to take a closer look at some specific applications of DeepSeek V3 and how it's actually being used to tackle those real-world challenges.
Stay tuned.
All right, welcome back to our final part of this DeepSeek V3 deep dive.
The grand finale.
We've taken this incredible journey through, the inner workings of this AI, its remarkable efficiency.
Those AI SATs.
Yeah, exactly. But now let's talk about what it can actually do.
Yeah, the real world applications.
Yeah, let's get practical.
Time to get practical.
What are you most excited about?
Well, one of the things that really stands out to me is DeepSeek V3's ability to, generate code.
Yeah, code generation.
It's not just about spitting out lines of code, It's about understanding what that code is supposed to do, the logic behind it.
So it's not just a code monkey.
Right.
It's actually understanding.
Understanding the functionality.
Yeah, the functionality.
That's pretty amazing.
Ah.
I mean, what kind of implications does that have then for software development?
Oh, it's huge, right? Imagine being able to just describe what you want your software to do.
Yeah.
And DeepSeek V3 just generates the code for you.
So no more late nights staring at your computer screen trying to figure out why your code isn't working.
Yeah, it's a developer's dream, right?
It really is.
Of course, it's not quite that simple yet in practice,
Right.
but it's definitely a step in that direction.
It's a huge step. And speaking of big steps, we keep talking about this open source thing. How does that factor into its potential?
I think it's one of the most exciting things about it.
Yeah.
Because it means that anyone, anywhere, can access it, modify it, build upon it, no crazy licensing fees.
No barriers to entry.
It's like democratizing AI in a sense.
It is, yeah.
I mean, is it easy to use, though, for developers? Is it something that anyone can just, pick up and start using? Or is it more, for advanced users?
That's a good question. Right now, using DeepSeek V3 effectively does require a certain level of technical expertise.
Okay.
It's not quite as simple as, downloading an app.
Right.
But the good news is that the research community, they're working hard to make it more accessible. They're developing new tools, new resources.
Okay, cool.
And as hardware gets better, those challenges are going to become less and less significant.
Right. So there are some hurdles, but the potential's undeniable.
It is.
I mean, this has been such an interesting conversation. It feels like we're right on the edge of something really big here.
It does, doesn't it?
This could really change things.
It could, yeah.
And, as much as AI can sometimes feel, a little bit scary,
Yeah.
it's also incredibly exciting. So much potential for good.
It's all about using it wisely, right?
Yeah, exactly. And responsibly. Well, that brings us to the end of our DeepSeek V3 deep dive. Thank you so much for joining me on this wild ride.
It's been a pleasure.
And to our listeners, remember to keep questioning, keep learning, and keep diving deep.
And keep exploring.
We'll see you next time.